So we've seen this. Now, we've got the systemic problem for the industry, and part of the reason is building performance evaluations tend to be called post-occupancy evaluation, and that tends to sound a bit like a post-mortem. As we've said, you know, being wise after the event is very threatening. You know, it's threatening to clients because they've spent the money, it's threatening to designers because, particularly we found to architects, engineers often, when confronted with the information, say, well, that's a bit disappointing, but I can work on that, whereas you tend to have more of a force field from architects, I'm afraid. There are also problems, obviously, in relation to insurance, and there's a whole thing of actually having more open transfer of information in the age of consequences, you know, closer connections as you're getting between what has been rather separate academic research and the reality of professional practice in making and improving buildings. The other problem is we've tended to develop quite simple but robust techniques, and people are always saying, oh, do you only want to do that? And then they want to do more and more, they pump the whole thing up, and then it becomes complicated and unaffordable. In fact, one of the best things that we ever did to Adrian's survey was to reduce it from what was about 20 pages to start with to 2, and there's even a 1-page survey now, because suddenly you've got something that people have time to fill in, managers let them, and you can actually grasp the results. If you want to drill down further, you can, but you don't need to until you've orientated your canvas. We've got this horrible sort of law of the commons, that everybody benefits from feedback, but if you stick your head above the parapet, it may get shot off. So we actually did some work which horrendously started 16 years ago now, in 1995, which were the probe studies in Building Services Journal, which ran until 2002, when that channel for research funding was cut off, because it was all about rethinking construction, wasn't it? Not about building performance. I don't know if any of you are aware of these things. Hands up people who've seen Pro. Not a lot. Well, the studies are still actually available on our website, Useful Buildings, so if you want to look at these, they are surprisingly still used in quite a number of university courses. And what we did is, for 20 buildings, sort of quarterly intervals over 7 years, we looked at buildings which had been written up in Building Services Journal about 3 years, between 2 and 5 years after completion, to find out how well the buildings which had been celebrated as fantastic when they were new were actually working. And what we found is the buildings that we looked at were generally performing a bit better than typically, not in all ways, but in some. But recurrent problems came up, though interface problems, between buildings which were often put together as work packages. So for instance, if you had a work package for the structure, and a work package for the roof, and a work package for the walls, then watch out where the walls meet the structure, watch out where the walls meet the foundations, watch out where the walls meet the roof, because thermal integrity may not be terribly good there. Integration of engineering systems into the physical structure of buildings, integration of occupants with controls and technologies, problems. Massive problems with controls. Whole lot of controls not at all usable. They're getting more sophisticated now, but they're still not very useful, unfortunately. Getting buildings handed over, in general, most design and building teams, you know, they give the client the keys and run away. You know, that's not terribly useful for complicated buildings. You need to tune up, follow through, feedback. And growing user dissatisfaction with internal environment. Buildings getting more prone to overheat, sometimes a consequence of better insulation, better air tightness, poor window design, and more internal gas. And then a whole lot about noise and unwanted interruptions, because often there's a philosophy that, you know, what you want to do is have a nice, buzzy, interacting environment. So you shove people into a small space, which you squeeze as small as possible to make it as cheap as possible per square metre to look after. But you don't realise that it's what Adrian calls the cocktail party effect. You know, if people get squeezed in too much, it all gets a bit noisy and difficult. Energy use much higher than anticipated. We talked about complication. what we found was complication was a big problem. It tended to be unmanageable complication that made the sick buildings in the 80s sick. It wasn't that actually there was something terribly bad with the design, or it was because if you had a building that wasn't being looked after properly, then something would fall over on the technical side. And if it fell over on the technical side, you could be pretty sure that something would be falling over on occupant comfort. In fact, one of the major correlates, Adrian, wasn't it, with building-related ill health, was whether the building was cleaned properly. So what we found worryingly was the complication that had been associated with air-conditioned buildings, and people used to say air-conditioned bad, naturally ventilated good, was actually migrating into the green buildings. Because the problem wasn't the air conditioning, it was the unmanageable complication. And so we had these lessons, and in general in the slides, blue's good and red's bad and black's just there. You know, clarity of design intent. People take for granted things like usability of controls, which are often absent. There are things that need to be put in there. The other thing is often interface packages in design, in management and technology to get things designed up properly. The importance of simplicity where you can. Some things have to be complicated, but often things don't have to be as complicated as we're making them. Unintended consequences. Every coin has two sides. There's a good side and a bad side. Often you can talk up the good side, forget the bad side, which may come and bite you, you know, like with the Challenger rocket when Feynman, the physicist, said that the inquiry, nature can't be fooled. In the end, the truth will out. And the whole thing about managing expectations, so you don't get these enormous credibility gaps between expectations and outcomes, sometimes for good reason. You can't achieve what you initially hoped to do because other constraints come along. Manage it. So, this is a Yorkshire mist in Harrogate. The building's the Homeowners Friendly Society. It's about the 7th of our probe things. This building, on paper, was the most energy efficient air-conditioned building in the data set we had. In practice, it was the least. The reason was that things that the design and building team thought could be taken for granted couldn't. And one of them was airtightness, because this wasn't unfortunately a mist coming from the outside, it was mist coming from the inside under a pressure test. So what happened was they had a well-specified cladding system mostly. You can see a vertical growth there that's failed. But they weren't specifying the sills, they weren't specifying the eaves. Now, this picture's worth, I don't know, a million words probably here. This picture got airtightness in the building regulations in 2002. Lots of people have done research, there were numbers and reports, but this picture was a spearhead for mobilizing all this information and saying, oh dear, these problems are not just happening to buildings in research samples, building A, building B, building C, mean and deciles and the rest. But this is happening to real buildings that we thought were rather good and are actually pulling the plug under them. Because if you have a well-performing facade with a low-energy air conditioning system that's not dealing with very high gains, and the facade doesn't perform as you intend, then the only thing a facilities manager can do is leave the air conditioning running 24/7, and that doesn't half make an enormous difference to the amount of energy you use. Now, often in modern construction, the buildings aren't massive, they're just, you know, a number of voids tied together with this, that, and the other. So actually, if you haven't got the airtightness right in design, if you haven't got it right in management and testing, and if you haven't designed it in such a way that you can fix it if you haven't got it right, you're a bit stuck. So this building had an air leakage index of 37. The current building regulation standard is slightly different definitions, air permeability, but let's just look at the numbers, is 10. And the recommended number for the sealed air-conditioned building is 5. But actually some people doing passive house buildings are getting 0.5. This was 37, and after trying to fix it, it went down to 35. It wasn't at all easy to fix it. So often, with this clever rethinking construction, getting things prefabricated and mechanized, whereas when you haven't got the attention to detail there, you can be stuffed. Now, here's a rather boring building at the University of East Anglia, which actually, for about 15 years, we surveyed it in 97, not quite 15 years, 12 years, was the best building in the data set, for summer comfort and pretty good for energy performance. And it didn't have air conditioning, it had thermal mass and night ventilation through the floor slabs. And it was also up for the Green Building Year of the Award, the Year Award in 1997. It didn't even make the shortlist. You can't tell by looking through the windows how these things are performing. This is the difference often between the award-winning building that Adrian showed you and the actuality. Often you can get good performance by doing some fairly simple basic things. You do not need the bling. But what you do need is commitment to delivery. And so what happened at this building, we actually talked to the design and building team, and then we had a seminar afterwards for all the people who've been involved in the first few stages of Pro. And we got them all together talking about their experiences. And interestingly, the team that was on the University of East Anglia Elizabeth Pride building said we haven't been able to replicate that. And unfortunately, they still haven't, 15 years later. Actually, getting the chemistry right here and getting these things happening is a pretty rare event when you get people together and they're all understand each other and committed to outcomes. And one of the reasons is they generally have to have done a project at least once before. Now, often the pack gets shuffled these days, or instead it gets shoved across to a framework agreement or a public finance initiative or something, which isn't actually driven by outcomes, it's driven by something else. Maybe driven by outputs, but outputs and outcomes are rather different. So you've got all these things happening, which actually reinforce the keep it simple and do it well agenda. But it wasn't quite like that, so we got 4 points with some red on, unfortunately. A bit of problems when they put it together, terrible problems on controls. They had to completely replace the heating and ventilation controls. They didn't have to. There wasn't any probably business case for doing it. In replacing it, they only saved a couple of £1,000 a year on gas bills because they're using so little gas already. But they wanted to demonstrate that this thing could work as well as it said on the tin. And so, having monitored it and understood what they needed to do, they found what they needed to do is control it more simply with a more sophisticated control system. As this building responded very, very slowly. It was an enormous thermal flywheel. So unless the control system had long-term monitoring built in, you couldn't tell what was happening.